There's a grave burning somewhere beyond the rings of Saturn. It does not hold a person, but it holds something human all the same. 20 years of ambition, $3 billion of engineering, and the last signal we ever received from one of the greatest machines we have ever built. Its name was Cassini. And what makes this story different from almost every other mission in the history of space exploration is this. We did not lose it. We did not miscalculate. We did not simply run out of fuel and watch helplessly as contact faded into silence. We aimed it straight at Saturn. We destroyed it on purpose. And the reason why, the reason NASA chose to burn its most beautiful explorer alive in the atmosphere of a giant planet, is one of the most unsettling and extraordinary discoveries of the space age. Because Cassini found something in the dark that was too important to contaminate. This is the story of the most beautiful and tragic mission of the modern space era, from the silence of deep space to the final transmission that told us everything, and then went quiet forever. To reach Saturn, a rocket was not enough. Saturn is so far away that you cannot simply point a spacecraft outward and fire. Cassini had to steal speed from other worlds. After launching in 1997, it swung past Venus twice, then Earth, then Jupiter, using gravity itself like a cosmic slingshot. Each flyby added speed, each planet donated momentum. By the time Cassini finally arrived at Saturn in 2004, it was moving at around 69,000 kilometers per hour, a bus-sized machine crossing the void between worlds on borrowed gravity. The trip took 7 years, and when Saturn finally filled the cameras, what Cassini found was not serenity. From Earth, the rings look smooth, elegant, almost unreal. A polished disk floating in blackness. Up close, they are a battlefield. Billions of fragments of water ice, from tiny grains to giant chunks, all racing in silence at immense speed. What looks delicate from far away is, in reality, a debris field vast enough to destroy a spacecraft in an instant. At those velocities, even a small particle can become a bullet. Not damage, vaporization. Cassini survived that world of ice, and what it revealed on the other side changed Saturn forever. The first shock was that Saturn is slowly consuming its own rings. This is not poetic language. Material from the rings is constantly falling into the planet's atmosphere in a phenomenon known as ring rain. Ice, dust, and organic material are being pulled downward by gravity, feeding the giant below. Saturn's most iconic feature is not permanent. It is fading. We are living in the era when the rings still exist, but they will not exist forever. And while Cassini watched them die, it also watched something else. In some places, the rings seemed to be doing the opposite. Material was clumping together. Tiny moonlets appeared to be forming at the edges, the same basic process that once built planets around the young sun. In other words, Saturn's rings were not just a relic of the past. They were a laboratory of creation and destruction happening at the same time. Then came one of the strangest sights in the entire solar system. At Saturn's North Pole, Cassini saw a storm shaped like a perfect hexagon. Not a rough pattern, not an illusion, a real six-sided structure in the atmosphere, more than 30,000 kilometers across, wider than Earth. A geometric wound in the clouds of a gas giant, sitting there where chaos should have ruled. Decades after Voyager first saw it, the hexagon was still there. Winds screamed around its edges. The storm endured. Saturn was not just beautiful, it was uncanny. And then there were the moons. Saturn does not merely have satellites, it has a whole empire of worlds. Shattered worlds, frozen worlds, scarred worlds, impossible worlds. Cassini turned tiny points of light into places with weather, chemistry, geology, and history. But 2 moons would define the mission, and one of them would seal its fate. The first was Titan. Titan is larger than Mercury, and wrapped in a thick orange atmosphere so dense that for decades nobody really knew what its surface looked like. Cassini studied it from orbit, but it also carried something more daring, the Huygens probe, built by the European Space Agency. In 2005, Huygens detached and descended through Titan's haze. What it found was one of the most eerie landscapes ever seen by human eyes. Titan has clouds. Titan has rain. Titan has rivers, lakes, and seas, but not made of water. On Titan, water is frozen as hard as rock. The flowing liquid there is methane and ethane. Hydrocarbon rain falls from the sky. Dark channels cut through the land. Shorelines trace the edges of alien seas. Huygens saw a world that looked hauntingly familiar in shape and completely alien in substance. It looked like Earth. Same logic, different chemistry, and that was the first warning. Maybe the ingredients for a living world are more flexible than we thought. Maybe habitability is not a narrow miracle that happened only once, in one place, under one exact recipe. Maybe the universe is far less strict than we imagined. But Titan was not the moon that changed everything. That moon was Enceladus. At first glance, Enceladus should have been just another icy moon. Small, bright, frozen, easy to ignore. Instead, it turned out to be one of the most important places in the entire solar system. When Cassini flew close to Enceladus, it saw something impossible. Enormous plumes erupting from the South Pole, jets of water vapor and ice grains blasting out into space from deep cracks in the surface, later nicknamed tiger stripes. This was not just surface frost. This was not sunlight knocking particles loose. This was activity from below. Cassini flew through those plumes again and again, and what it found transformed Enceladus from a frozen moon into a scientific obsession. The plume material contained water, salts, organic compounds, and molecular hydrogen, clues pointing toward a warm ocean hidden beneath the ice, an ocean in contact with rock below, with chemistry that on Earth is associated with hydrothermal systems on the seafloor. In other words, Enceladus had the ingredients that make scientists very nervous in the best possible way. Liquid water, energy, organic chemistry, not proof of life, but the kind of environment where life could be possible. And that was the moment Cassini's story changed. It was no longer just a mission of exploration, it became an ethical problem. Because once you discover that a place may be habitable, the rules change. A spacecraft is never perfectly sterile forever. Cassini had done its job magnificently, but by then it was running out of fuel. And fuel does not just move a spacecraft. It keeps it under control. It keeps its antenna pointed, its orientation stable, its path precise. Once that fuel was gone, Cassini would no longer be fully controllable. And if an uncontrolled spacecraft keeps drifting long enough through the Saturn system, one day it may hit something. That something could have been Titan. Or worse, Enceladus. And if Earth microbes carried on the spacecraft reached a moon with a potentially habitable ocean beneath its ice, we could contaminate it forever. We could destroy or confuse the very thing we hoped one day to discover. We could arrive at one of the greatest scientific questions in history. Are we alone? And ruin the answer before we even got there. That was unacceptable, not because NASA knew life existed there, but because Cassini had revealed enough to make caution mandatory. So the mission team made the hardest decision of all. Cassini had to die. Not because it failed, because it succeeded too well. If it could no longer be trusted to stay clear of those moons forever, then it would be sent into Saturn itself. The planet would become both its final destination and its grave. But even in death, Cassini would keep exploring. This final phase of the mission became known as the Grand Finale. After one last gravity assist from Titan, Cassini began a series of daring orbits diving through the narrow gap between Saturn and its innermost rings, a region no spacecraft had ever entered before. Even at the very end, it was still going where nothing had gone before. Those final orbits were not ceremonial. They were dangerous and scientifically priceless. Cassini measured Saturn's gravity with new precision. It sampled the particle environment. It studied the ring system from the inside. It watched the giant up close in ways no future mission is likely to repeat anytime soon. It was still working, still discovering, still sending home one last flood of knowledge before the end. Then came September 15th, 2017. The final descent. Cassini plunged into Saturn's upper atmosphere at around 123,000 kilometers per hour. As the air thickened, the spacecraft's thrusters fired continuously, fighting to keep its antenna pointed toward Earth for as long as possible. For a brief moment, it was a duel between human engineering and a giant planet. Cassini was never meant to survive that fight, but it kept transmitting anyway. Its final signal crossed roughly 1.4 billion kilometers of space. Every second mattered. Every second brought back one last stream of data from inside Saturn's atmosphere, measurements taken from a place no probe had ever sampled like this before. And then the atmosphere won. The spacecraft lost control. The signal stopped. No triumphant final image, no cinematic explosion in the sky. Just a machine that had traveled for 20 years, crossed billions of kilometers, and transformed our understanding of the solar system being torn apart in the clouds of a world it had spent so long teaching us to see. Cassini became plasma over Saturn. And somehow, that makes the ending even more beautiful. Because this was not a story about a machine that failed in deep space. It was the story of a machine we loved enough to destroy. A mission so successful that the only ethical ending was sacrifice. Cassini showed us that Saturn is not just a planet with rings, it is a system of living processes, storms, chemistry, oceans, weather, hidden energy, and worlds that may be far more interesting than anyone had dared to believe. Titan changed the way we think about planetary chemistry. Enceladus changed the way we think about habitability. Saturn itself changed from a symbol into a place. That is Cassini's real legacy. Not just the images, though they were unforgettable. Not just the discoveries, though they were historic. But the fact that it forced us to become more careful. Its final act was not conquest. It was restraint. Humanity reached into one of the most extraordinary planetary systems in the solar system, found something too valuable to risk harming, and chose not to leave a careless mark behind. Someday, new missions will follow the trail Cassini opened. They will return to Titan. They will return to Enceladus. And when they do, they will not be going back to blank mysteries. They will be going back to worlds Cassini made real. Until then, somewhere in the darkness, the farthest grave we have ever made is still burning in memory. Cassini is gone, but in a way it is still there, dissolved into the planet it spent years teaching us how to see. And for a machine built by human hands, there may have been no nobler ending than that. If this is the kind of story that reminds you how extraordinary the universe really is, subscribe for more.